Hello, hello, I'm Mrs. Edwards and it is time to do math and I love it. Today we're going to go through finding the area of a sector and also the arc length. You might want to jot down these formulas because you're going to need these formulas as we work through some of these examples. Before we go to those specific examples, let's go ahead and define some of these variables. So capital A here, that represents the area of the sector. Looking here at my diagram, that blue shaded region, that pie slice, that is the sector. So A stands for the area of that pie slice. R, of course, stands for radius, and then theta represents the angle measure that forms that sector. Okay, moving on to arc length, the variable S represents the length of the arc. So notice here in red, I have an arc, and so S would represent the length of that arc. Again, R for radius and theta for the angle measure. I think most of those variables are pretty self-evident. However, I do find that students sometimes forget what the variable S represents. So maybe silly story to help you connect it. The letter S, just think about the letter S. It is very curvy. Okay, so letter S represents that curve, that arc length. Furthermore, to use these two equations, the key is that the angle measure you substitute in must be in radians. You can't substitute 45 degrees. You would have to change that to pi over 4 before you make the substitution. So I am going to say that one more time because that's the common mistake using these formulas. Be sure when you substitute an angle in for theta that angle is not in degrees, but is measured in radians. All right, let's go ahead and take a look at a few examples. In this first example, we just want to find the arc length of this sector. So we want to find the length of that red curve right there. Of course, we're going to grab the formula for arc length, S equals R theta. When we go to substitute in the radius and the theta, remember the key is the angle measure you substitute in must be in radians. So starting with 50 degrees, we need to convert that into radians. To do that, we just multiply by pi over 180 degrees. 50 is over 1, so multiplying straight across, we have 50 pi over 180. We might want to simplify that by dividing the numerator and denominator by 10. So the angle measure in simplified form is 5 pi over 18. Now that we have theta in terms of radians, we have everything to substitute into this formula. So S, the arc length, is the radius, which was 5 inches, multiplied by the angle measure, 5 pi over 18. The 5 there is over 1, so let's just multiply across. That gives us 25 pi over 18. Now, if you want an estimate, multiply 25 times pi and divide that by 18. So we find out that this arc length right there is about 4.36 inches. This example is an application of finding arc length. So we have this pulley that this guy is pulling on, and it's going to lift up this weight. Now, the angle measure that pulling this string is going to move through is going to be 50 degrees. So if you can picture that rotating 50 degrees. Now, when you rotate this 50 degrees, that arc length right there is going to then pull this weight up that exact same distance that you have that arc length. So ultimately, if we want to find out how far this weight is going to come up off of the ground, we're just going to find the arc length, and then that will be the same thing as how far it was lifted. Okay, so Let's start with our formula. 50 degrees, however, is in degrees and we need it in radians. So let's multiply that by pi over 180 to convert the angle measure to radians. We end up with 5 pi over 18. Now we have everything we need. The radius multiplied by the angle measure in terms of radians is 25 pi over 18, which is about 4.36 inches. So picture that one more time. You're rotating that 50 degrees. And so as that pulls across, that arc length is equivalent to how far it comes off the ground. So let's do just one more example of finding the arc length before we move on to area of a sector. So in this particular instance, notice that the angle measure given is already in terms of radians. So we're not going to have to convert the angle measure from degrees to radians. We just start off with everything we need to know. So I'm going to put 5 in for the radius, the angle measure pi over 7 there in for theta, multiply those together, and the arc length, the length of that red curve there is 5 pi over 7. 5 times pi divided by 7 is 2.24-ish, which is just an estimate for how long that arc length is. So in this example, we're moving on to finding the area of a sector. So in other words, we want to find the area of that blue pie slice. So we have our formula written out here for the area of a sector, and we want to substitute in the radius and the angle measure. But please keep in mind, when you substitute in an angle measure into this formula, the angle measure must be in radians. So first thing I'm going to do is take the 50 degrees and convert it into radians by multiplying by pi over 180 degrees. I end up getting 5 pi over 18. Now I have everything I need to substitute into my formula. So area is 1/2 times the radius, which is 5 squared, times the angle measure theta, which is 5 pi over 18. We really have here 1 over 2 multiplied by 25 over 1 multiplied by 5 pi over 18. So you're just going to multiply straight across, and we end up with 125 pi over 36. I'm going to go ahead and multiply 125 times pi, divide that by 36, and we have an estimated area of 10.91 square inches. So I think you'll find these two formulas to be relatively easy to use, provided you remember that whenever you want to substitute an angle measure, be sure not to substitute an angle in degrees, but substitute an angle measure in terms of radians. I want to go ahead and make just a quick connection. Let's say that you wanted to know the area of the entire circle rather than just one little pie slice. Well, if you wanted the area of the entire circle, then what would the angle measure be? If we go all the way around, that's 360 degrees, but we don't want to use degrees, so I'm going to say that theta is 2 pi. If I substitute the angle measure with 2 pi, then the 2's would cancel, leaving us with pi r squared, which is the area for a circle.